Problem is called gas station problem, and it has been asked quite a few times in Amazon, Google, Microsoft, Uber, and Apple interviews. So let's see what is this problem. So in this problem, you have a few gas stations. So this array or list of gas denotes the different gas stations. So gas station 0, 1, 2, 3, 4. So let's draw them here. So you have to think that they are in a circle. So you visit these gas stations in a circular fashion. And you can start from any of those. So let's say this is 0, this is 1, this is 2, this is 3, and this is 4. These are the 5 gas stations. And these are different capacities which you can fill your car with. So when you go to gas station 0, you can take 1 unit of fuel from this. And this cost, which is of same size as this, denotes that cost 0 will denote that you need at least 3 units of fuel to go to next station. That is, if you are at 0, next would be 1. So you have to go in this clockwise fashion. So you need 3 units to go from 0 to 1. So let's say you start from 0. So you can fill with your car with 1 unit of fuel, but you need 3 units to go to 1. So you cannot do that. So initially your car is empty. The tank of your car is empty. So this is not possible. You cannot start from here. Similarly, when you start from here, you will fill it with 2 units. So you have 2 units of fuel, but at 1, you need 4 units to go to 2. So again, you cannot make this trip. So you will also not start from here. So what thing we are checking, that gas I should be greater than or equal to cost I in order to start from there. So we can think of this as a difference or surplus. So let's call it delta gas I minus cost I. This should be positive in order to start. So till you are getting negative, you cannot start. Now here, look at this. Gas you can fill is 3, but you need 5. Again, not possible. Here, you can fill your tank with 4 units of fuel, and you need just 1 unit to go from 3 to 4. So you can start from here. You will start or not will depend on the future values. But here you can definitely start, since here you will have surplus. So here we filled with plus 4 unit. Then we came here, we lost 1 unit because we need 1 unit. So minus 1. Now we have a surplus of 3. At 4, we can fill another 5. So 3 plus 5, 8. Now we have 8. And we come here and we lose 2 units of fuel. So now we have 6 here. So we fill with 1, so 7. We consume 3 when going here, so minus 3. So now we have 4 and we fill with 2, so 6. Then we consume 4 units, so minus 4. Now we have 2 here and we fill with 3, so 5. And when going from here to here, we need 5 units, so minus 5. And now it becomes 0. So we have completed a trip. We started from here and we reached here. So this is what we are required to answer here. So what should be the starting index? So in this case, the answer should be 3. Because we can start from here and complete a round trip. And another thing to note is that, let's say the total cost is more than total gas available. Then definitely you cannot make any trip no matter where you start. Because let's say you have cost is 50 units of fuel and total available fuel is just 45 units. Then no matter where you start, you cannot complete the trip. So this is another point. This total should be always more than this, or that is total delta, sum of deltas should be positive or 0, greater than equal to 0. In this case, it was exactly 0. So that was good enough. Now is the problem for finding the starting point. So you can also draw this circle here, 0, 1, 2, 3, and 4. So you start in this direction and then go back to 0. So let's see how we will find the starting point. So let's take a general example. Let's say we have some points. And I will draw just one point. Let's merge these two into one. This cost and gas with this delta. that is gas minus cost. So it should be, if it's greater than equal to 0 at a given point, we can start from there. So what we will do, we will keep track of two variables. We also need this total. Maybe you started from here and reached here, but overall total was less than 0, this total delta. Then we cannot complete the journey. So we keep track of two variables, total delta and current delta. So let's say it's negative here, negative, negative. So you start from here, you see it's negative. So you come here, you reset everything to 0. So initially it's 0, both are 0. We have not started yet. So when it's negative, let's say it's negative A, negative B, then it's plus C. So this will keep incrementing, you will keep accumulating. This is nothing but accumulator, and in the end we will just use it to check if it's less than 0 or not. If it's less than 0, we will straight away return false. Otherwise we will return the starting point. So you can even forget this for now. This is just accumulator, no other purpose. So we come here, we check what is current delta. So current delta will be current delta plus this value. Let's call it. So this is nothing but gas I minus cost I. So this is the delta. So we are adding. So initially it was 0. Now it becomes, if it's negative, then it's minus. So if it's negative, we will not start journey from here, or whatever was our previous starting point. So we started from some point and we moved to some points and we reached here, and now it has become negative. That means this starting point was invalid, because when we start from here, now once we reach here, it's negative. So it was false. It was wrong starting point. We cannot complete the journey. So what can be the next starting point after this? Why not here or here? Let's see. Let's see, we started from here and this point was positive. This delta was positive. That's why we started. Otherwise we cannot even start. Next, let's say it was also positive. So you'd say that why you reset the starting point only when the current running delta becomes negative. Why not try from this point also? This is also positive. We don't try from this point because when we started from this point, when our car reached here, this is the starting point. So our fuel was 0. So it was exactly 0 when we came here, and we loaded our tank with this fuel. So when we go from here to here, we already have something positive. If it becomes negative, we are resetting it anyway. So we are not resetting it. That means we reached with some positive capacity, or in the worst case, maybe 0, not less than 0. So we reached with some positive capacity. So obviously this point is better, because if you start from here, you reach this point with some positive delta, and then you will add this value also, the tank, the fuel capacity at this station. So total will be more. So you have this fuel capacity, gas I, this you will load, and you already reach with this positive delta. So now it will become plus delta. But if you start from here, its value will be just GI. So it's always better to start from here. So that's why starting from any of these intermediate points will not be better than this one. So we will start from here, and when the running delta becomes negative, then we know that the starting point was invalid. And if starting from here we reach a negative value, then starting from here also we will reach negative when we reach here, because when we start from here, our tank will have even less value, GI. When we start from here, our tank had GI plus delta. So GI plus delta becomes negative, that means GI will also become negative. So this was the best starting point that we chose, and still we got negative. So this was invalid. So next starting point will be 1 after this, because this was negative anyway, that's why the overall became negative. So next we will start from here, and again the same logic. If it's remaining positive, we will continue. If at any point of time it becomes negative, then we start from here. And when we reach the end and the value is greater than equal to 0, then we know that from this starting point S we have reached here with some positive capacity left. Then we check if the total delta is greater than 0 or not. So if it's less than 0, no point in checking further, return false. Total is less than 0, no, there is no way we can reach. But if this total is greater than 0 or equal to 0, then return this starting point. This will be a valid starting point. Now, in this problem, we have seen that from here, when we started from here, we did not face any such situation where it became negative. Otherwise, we would have reset it. We did not reset till the end. That means from here, we have reached till here. Now, our only concern is that we have to prove that with whatever capacity we have here, delta, we can reach from this 0 till this node. And if we can prove that, we are done. So this is now guaranteed that T delta is greater than 0. Otherwise, we will return false. So now we have these things. So we have, this is the starting point. From where, when we started, we reached end point. So let's call it N for nth point. And this is 0, starting point. And this is the last starting point that did not violate anything, and we reached till end. So reaching from here to here is valid, we have seen. And total delta is greater than 0 or greater than equal to 0. Now we have to prove that we can reach from 0 to S in this round trip. So after this, we go here. So at nth point, we added the capacity of G n minus 1 and subtracted cost n minus 1. And if it's positive, that means we can go to 0. So from S, we can go to 0. So we are here at 0. So here we will again add the cost for 0 plus G0 and subtract cost 0. So we have to prove that from 0 we can reach S with this surplus plus delta. We reached here with plus delta. So let's say we cannot reach from 0 to S. Let's prove it by contradiction. So let's say from S to N we successfully came. Then from N we go to 0 because it was greater than equal to 0, this difference. Now from 0 we started moving at some direction at next gas stations, and somewhere at this gas station, let's say point P, it became negative. So if we face such situation, then we will say that we cannot complete the trip when we start from S. But we have to prove that such point will not exist if total delta was greater than equal to 0. This thing. So let's assume that there is a such point where it's negative. Then what is the condition for this to be negative? We started from here when our capacity was 0. So this point, let's call it X, this part, and let's call it this part as Y and this part as Z. So X plus Y plus Z will be this total delta. So this we know that is greater than equal to 0. This is equation 1. This is same as this variable that we were keeping track of here. Cumulative sum. So this is greater than equal to 0. Otherwise we would have returned earlier only. So this is first equation. Next we stop here. That is from S we cannot go past 5. Go past P. So what this means? This part is X and this part is Y. So that means this is less than 0. That's why we have got a overall negative when we reach here. We started with 0, now it's negative. So this X plus Y is negative. This is second. So X plus Y is negative. Okay, this is negative. And this complete thing is positive. So Z is positive. Now if Z is positive, from this first and second equation, if we combine this, clearly Z has to be positive, then only this negative plus some positive will make it positive. So if Z is positive, we would have started before only, not S. Why? Because we had some positive values. Let's break the Z. This is Z. We are looking at Z. So Z will have some positive, some negative, some positive, we are merging positives together. So this, if we have plus plus plus, then we would take it as 1 plus. So it would have different regions of positive and negative, and this overall is positive. We are in the contradiction part only. So if, let's say this part, so if this positive was more than negative, that is this much positive and this much negative, so this positive is more. So if we start from here, when we reach here, we will still have some positive left, and then this positive again will add to it, so we will have even more positive, and we know that it's positive, so we will successfully cross this. So we would have never reached negative here. We started from here because just before it was negative. So in that case, we would have started from P only. So this is the first case where this positive was more. Now let's say this positive is less, negative was more. Then what will happen? We start from here. When we reach here, overall it's negative. So we would have started from here. So this part is now negative, overall sum. This plus, let's say plus 2 minus 4. So this overall becomes negative. So now it becomes minus plus minus. So we would have started from here. And we had said that this complete thing is positive. So this thing also will be positive. So again, by the same logic, if you start from here, you would cross this with positive, since the total is positive. So that contradicts that z cannot be greater than 0. So z will be less than 0. Now we arrive at a contradiction. From 1 and 2, if such point P exists, then from 1 and 2, this z has to be positive. But we have shown that z will be negative. That's why we started from here. So we arrive at a contradiction, and such point P will not exist at all. So what will be our strategy? What we had done? We started from here. We kept two variables. One is for running delta or surplus. Other is cumulative. This cumulative is not used anywhere. It's used just when we complete this iteration. We check if cumulative is negative, return false, else return the last starting point. And we started from here, and we at every point we added this value to both the current delta and total delta. And at any point of time, if current delta is negative, then we reset it, because our starting point was wrong. So we start from next point. So that's why we reset. And finally, when it's greater than 0, then we return the starting point. So let's write the code for this. Understanding is, this is more tough. Writing the code is very simple, just a few lines of code. And in this problem, it's given that it's a unique solution, but that does not make a difference. We are already picking the best starting point possible. So even if it's not unique, we would return a valid starting point. Both sizes are equal. You can pick any of those. Total surplus. It's not the total fuel. Total fuel will be the sum of all values here. And we are subtracting total cost. So total surplus equal to 0. And current surplus, or just write surplus, equal to 0. Next, starting point, let's denote by capital S, is 0. This is the first starting point. Gas I minus cost I, and the same thing will be added to surplus. So if surplus becomes negative, then the starting point was wrong, so we reset it, and starting point S becomes next point, because this current point is a big negative. That's why the total became negative. Earlier it was positive. And when this loop ends, we will check if this total surplus is negative, then return -1. So if the solution does not exist, you have to return -1, otherwise the actual index. So we can combine it into one, return with this statement, ternary operator, then return -1, else return the starting point s. And let's see. So this answer is correct and the solution is accepted. So now what is the time complexity of this solution? We are just iterating through this array. Both are same size and we are traversing from left to right. So this is O of n. So time complexity is O of n. And space, we are just keeping a few variables like total surplus and starting point. So space complexity is O of 1. Now let's write the same thing in Java and Python. And the solution is accepted in Java also. Finally, Python. -1 if total surplus is less than 0, else else s. And the Python solution is also accepted.